Good morning, students. How are you? I think you all are well at home and hoping for your goodness. So, in continuation with my video lectures on motion in a straight line, we had covered up to the topic frame of reference. Now, today, date is 28 part 4. Today is part 4 of chapter 3, that is motion in a straight line. And in today's video we will discuss about path length or distance. Path length or distance. Path length or distance. As you had already studied about path length, you had studied in class 9th also path length. Path length is nothing. Path length is the length of the path covered by any object or any person during its motion. So the length of path covered by any object during its motion. It is known as path length, called as path length or distance covered. Path length or distance, it is called as path length or distance covered. To understand path length, I am taking an example. Look at here. This is y-axis and this is x-axis. This is y-axis. Now suppose an object moves along x-axis to a distance of 100 meter. And object is moving, this is point A, and object is moving from origin O to point A, position A at time t. Clear? Path length is 100 meter. This path length is what? This path length is and this is 100 meter. This path length is 100 meter. Now if the object returns to the origin in time t dash, if the object returns back to the origin, after going there it returns back to the origin, then this is the position, again this is the position returning back a t dash time. After t dash time it will return back to its origin. So the total distance or path covered by the object is 100 plus 100. So path length is 80 plus a t dash, that is equal to, or you can say it as o t dash, whatever you can say it, 80 or o t dash, and it is equal to 100 meter plus 100, and it is equal to 200 meter. Means the distance covered by the object or the path, whatever the path followed. Suppose here an object and it has to reach this destination and he had followed this path, then how can you find out the path length? There is no any suitable scale to measure these curved lines. So for this, what we will do, you will tie a string here and the same path is covered by the string. Now strengthen the string and measure the length of the string. That will be the path length. If an object is considering a circular path, then whatever the circumference of this circle will be the path length covered by the object. So these are the path length or distance covered by the object. Since there is no direction, here there is no direction, here there is no direction. Since it has no direction, object is moving in this direction, all the directions are taken as positive, no direction is here, positive or negative, no direction is here. So it is called as a scalar quantity. So path length is a scalar quantity which has magnitude but no direction. It has only magnitude. It has only magnitude but no direction. It has only magnitude but no direction. There is no any direction. Now we are going to solve a numerical over that, and after that we will discuss about displacement. So let us solve a numerical based on this. Let us solve a numerical based on this. Look at the question. A scooter is moving along a straight line AB covers a distance of 360 meter in 24 hours and returns back from B to C and covers 240 meter in 18 seconds. Find total path length traveled. Find the total path length traveled. Find the total path length traveled. You have to find the total path or length traveled. What is the total path length? As simple as that. Very simple, simplest question. A body starts from A and goes to B, and from A to B it covers 360 meter. Then it returns back to C and covers a distance of 240 meter. So we need not to say anything about time and anything else. Since path length, whatever the path length, simply adding path length is equal to AB plus BC, and it is equal to 360 meter plus 240 meter, and it is 600 meter. That is equal to 600 meter. Now we have to discuss about displacement. What is the meaning of displacement? Next discussion is about displacement. Displacement. Displacement is nothing. Displacement is just like distance or path traveled, just like path traveled, but the simple variation is that the direction is included with the path traveled. If direction is included with the path traveled, then that distance becomes displacement. Suppose here A and here point B. There are three paths. Suppose this one, and this one. So there is no any particular direction in this case, there is no any particular direction in this case, but it here has direction. And if the particular direction is added with the path traveled, if particular direction is added with the path traveled, then that distance will be the shortest distance. Then that distance will be the shortest distance, and it will become displacement. Suppose you have to, suppose this is your school and you have to go to Padri Bazaar. Padri Bazaar. Now there are various ways to go to Padri Bazaar. You will go Padri Bazaar by going through, suppose, Nandanagar, then Kuda Ghat, and just like that. Another way through Michia, and this is a direct way from school to Padri Bazaar. So this is the straight path from school to Padri Bazaar. This is the shortest path. This is the shortest path. And this is nothing. This is displacement. Displacement means what you are seeing that, okay, distance must be equal to, this must be the displacement must be equal to distance when the body is traveling in the straight line, or you can say that displacement is equal to distance, but displacement will never be greater than distance, since displacement is the shortest path. Since displacement is the shortest path, so it can never be greater than the distance, but distance is equal to the displacement. If a body is moving in a straight line, then you can say that the distance covered by the body is equal to the displacement. So you can say that the displacement of the body, displacement of a body is equal to final position minus initial position. In nutshell, I want to describe this thing, final position to initial position. Suppose you have to find the displacement between your school to Padri Bazaar. So for finding the displacement between your school to Padri Bazaar, first of all, your final position is what? From a reference point, you will measure the displacement of Padri Bazaar, and from a reference point you will measure the displacement of, just look at here. Suppose this is your school and this is Padri Bazaar. This is the school and this is Padri Bazaar. Now this is your reference point, origin, and suppose your school is at a displacement or position. Your school is at or position, initial position x1, and Padri Bazaar is the final destination x2. Now it is asked that what is the displacement between Padri Bazaar. So you will say that it will be x2 minus x1. Position, final position minus initial position. Final position minus initial position will give the displacement. Final position minus initial position will give the displacement. Now from here, if x2 is greater than x1, this is greater than this one, then displacement will become what? Displacement, it is equal to positive. If x2 is less than x1, then displacement is equal to negative displacement. And if final position and initial position are same, that is x2 is equal to x1, then displacement is equal to 0. Then displacement is equal to, if final position is equal to initial position, then displacement will become 0. So in nutshell, we can write that the change in position, of an object in a particular direction is termed as displacement. And displacement delta x, that is equal to x2 minus x1. x2 minus x1 is the displacement. x2 is equal to final position and x1 is equal to initial. x1 is equal to initial position. From here, if x2 is greater than x1, then delta x is equal to positive, x2 is less than x1, delta x is equal to negative, and x2 is equal to x1, then delta x is equal to 0, then displacement is equal to 0. Like if an object is traveling from here and comes to here, the initial and final position are same, so in this case displacement is 0. So displacement of a body can be positive, negative or 0. It is a vector quantity as it possesses both magnitude and direction. It is a vector quantity. Magnitude of displacement may or may not be equal to path length traversed by the object. Magnitude of displacement for a course of motion may be 0, but the corresponding path length can never be 0. Path displacement is equal to 0. Displacement, these are point of differences. Displacement can be 0, but path length can never be 0. Path length can never be 0. Path length can never be 0. These are the points of differences. Now, regarding displacement, we are going to solve a question. Look at the question. A boy starts moving from -20 meter towards positive axis and he turns at time t2 and starts moving towards negative axis at time t3. At time t3 he reached at -50 meter. He reached at -50 meter. Find the distance and displacement for the time interval first t1 to t2 and second t1 to t3. Now look at the question. It is given that a boy -20 meter at time t1, the position of the boy at time t1 the position of the boy is -20 meter. After -10, 0, 10, 20, 30, 40, 50, he reaches to the position 50 at time t2, and again at time t3 -50, -30, -40, -50. This is the position of the boy at time t3. This is the position of the boy at time t3. This is positive x-axis and this is negative axis. First the wire travels from here to here. So what is, find the distance and displacement. So distance in this case for tan tube, so this is distance is a scalar quantity. It need not to do with a positive or negative. So 20 plus 50. T1 to T2 distance is 50, and displacement is final position minus initial position. Final position minus initial position. So final position is, it is given, it returns to and starts moving towards positive x-axis. So final position is 50 minus 20, 50 minus 20, and it is equal to 50 plus 20, that is equal to 70 meter. So you can do it. It is easy for you to do it by your own. I had explained it from T1 to T3. So from T1 to T3 means T1 to T3. So means T1 to T2. So T1 to T2, 50 plus 20, 70, and 50 plus 20, 70, or and 70 plus 50, then 50, 100, 70 plus 100, 170, and minus 50 final position, final position minus 50, or initial position minus 20. Initial position is minus 20 minus 50, minus 50 minus 20, that is equal to minus 30 towards negative x-axis. It is easy for you. You all will do it, and in the next video we will discuss about uniform motion in a straight line, and we will come to the graphical approach for motion in a straight line. So, and after that we will discuss velocity and all these things we will discuss. So that's all for today, students. Thank you, students. Have a nice day. Take care. Thanks.